So here we are demoing the full application. Right now we have Marco in the car pulling up to a parking spot with an already QR code and a PIR sensor. The camera is already attached to the car as well as the microcontroller. And here he comes pulling up. So he's got to get lined up with that QR code. Once he gets close enough, he'll turn on the onboard camera. PIR sensor will trigger, notifying that the spot is occupied. And it looks like it's all scanned.
This is a demo of the custom PCB with the PIR sensor to detect the occupancy state of a parking spot. As you can see on our mobile app right now, on the second floor of Garage I, we have 226 spots full of 823. Now if I reverse out of this spot, it should trigger the PCB to update that database accordingly. Now if we check the mobile app again, was 226, should now be 225. And there we have it. If I pull back in, should update back to 226. Was 225, and there we have 226. This video is to demonstrate the limited range of the PIR sensor so as not to detect false positives from pedestrians or other cars. We have the sensor set up here in this empty parking spot in between these two cars. As we can see in Garage I, there are 225 spots open out of 823. If I simulate a pedestrian walking past the sensor, we will see that it will not trigger an update in the database. And it still is 225. The previous demo showed how we were able to limit the range of the sensor to as not detect false positives from pedestrians walking in the parking garage. We used an onboard potentiometer in order to set the range of the sensor to the length of a parking space. However, if a pedestrian is walking within the range in a parking spot, it will trigger the sensor and update the database accordingly. Here we see that Garage I has 225 spaces full of 823. To simulate a pedestrian walking within the range of a sensor in the parking spot, I will move in front of the sensor, and we should see that it will update the database accordingly. Previously 225. Now 226.
Once the user is ready to leave the spot, all they gotta do is click on remove vehicle location and it will successfully remove the store location. That's it. Also, they can just simply either press X or click exit the application to fully close the application.
This is a demonstration of our project, Ucf Go. We're here in parking garage I looking for a parking spot. So if we go to the mobile app, we can go to show available spots, go to garage I, and we can see that there are 225 spots full out of 823, so there should be lots of parking. There's a parking spot right ahead of us that has a sensor on it that should trigger an occupancy state change when we do pull into it, and then it also has a QR code so that we can save our parking spot for when we're coming back to our car. That being said, we'll go ahead and pull into the spot. We will use this display inside of the vehicle to scan the QR code so we can remember where we parked. You can see that it says we successfully saved the parking spot. So if we go to find my car, you can see that we parked in garage I on the first floor in spot 5. If we go to show available spots, it was previously 225 spots full. It should now be 226 because of the sensor. So at the end of the day, once you have used the application to find your car and you want to remove the saved location, you can use the display inside of the vehicle and click remove vehicle location. You can see that it removed the saved spot, and then if you try to find your car, you'll get a warning that it is not registered because you have not saved a spot and it is ready for the next time you park.